First off, I want to thank Alooma for giving me the opportunity to come here and speak in front of you all. We had a really great customer advisory board meeting this morning, and I think there's some really exciting stuff coming in the future. This talk today is going to largely be about what the future is for Strava. So I'll give you the tour de data, how Strava uses data today to inspire athletes, but also very much about how we aspire to use data in the future. So what is Strava? Strava is the social network for athletes. So our mission is to build the most engaged community of athletes in the world. We're a mobile app and a website, and we focus primarily today on runners, cyclists, and swimmers, but also much more. Really any activity that you can do outside with a GPS track. In this case, this screenshot here, somebody has ridden 40 miles. They've gone for 4 hours. They've climbed 3,000 feet of elevation, and if you look carefully, you see they've drawn a dinosaur on their map. So people use Strava to upload activities and connect and compete with their friends. About myself, I've been at Strava for about 4.5 years now, and I manage the data engineering group there. One interesting thing I've found about data engineering, and I'm sure many of you have found this to be true as well, is a lot of data engineers, for some reason, don't actually come from traditional computer science backgrounds. So that includes myself. I'm initially from an economics and statistics background. I picked up data engineering sort of later on in my career. I'm an avid cyclist and swimmer, so Strava is a really good home for me. So I guess really what I'll be talking about today is data. Data is a lot of what Alooma provides, and data is really the heart of Strava's product. So with Strava, you give us your data, and we give you insights back. So this screenshot is from a feature we call the workout analysis. And this is an example of what I would call transactional analytics. In this case, you're giving us your data, and we'll give you some interesting stats like your distance, your pace, how long were you out there, how much elevation did you climb. And this is really, really interesting, and a lot of people want to know this stuff, but I would say this is not really Strava's special sauce. I think you look at all of our competitors out there, and a lot of them will offer something similar like this. Apple will do this natively on the Apple Watch. Garmin will do this. I think what really makes Strava special is what I would call, I guess, I don't really have a catchy name for it, but really when we take your data and we put it in context with the world around you. So we're not just taking your data and giving you, doing analytics in isolation, but we're taking it with all of our knowledge of the world and putting your data side by side with that and really giving you insights that you wouldn't have access to otherwise. So this screenshot here is a feature that we call segment leaderboards. So in this case, any user can define an arbitrary track of GPS, and we will go back through all of history of anybody who's uploaded their data to Strava and compute a leaderboard. What are the number of people that have done this segment before, and who's the fastest? How do you compare to all those people? How do you compare relative to your age or gender or weight cohort? And that's, to me, really, really cool. Another example would be this feature we call group activity matching. So did you actually, in the real world, so a lot of these sports, bike rides, running, swimming, a lot of them are social sports, and you do them with people. So in this case, if you do a ride or a run, or in this case, a swim with a bunch of other people, and all of those people upload their data to Strava, we can take all that data and put it together and say, hey, you actually rode with this person. You ran with this person. When I was first using Strava, this was really the killer feature for me, because this was sort of a way that we were able to take, or I was able to take a physical interaction that I had in the real world and solidify it via an online interaction. So I could ride with a new group of people, meet 4 people in the real world, and then later that afternoon connect with them on Strava and say, hey, it was really good meeting with you. Next time I see them, it's a lot easier to sort of pick up that conversation. Hey, remember that last time we rode together? That was really fun. So this really helped me find my community here in San Francisco. So we have all these really cool features. But one point I really want to stress is advanced features really require advanced capabilities. So it's really hard to imagine implementing any of these features that I've discussed with just a simple SQL query on a transactional database. So, and oftentimes, these resources that scan massive amounts of data are really expensive to build and maintain. So the question that I kind of want to explore and figure out is how do we make these kinds of features easier to build and easier to maintain? So to back up a little bit, I'll start way, way back and just talk about our data warehouse journey at Strava. So before I joined Strava, there was no such thing as a data warehouse. People were running queries on the production databases, and no one likes that. So we started off on Amazon Redshift, as I'm sure a lot of you have done the same. The primary focus of Redshift was really on business intelligence. So how do we just get a basic understanding of what are people doing on our application? How are people using it? How many users do we have even? These are really basic questions that are actually surprisingly hard to answer if you're just writing pretty expensive queries on your production databases. To further open up that data, we introduced Looker as our first BI tool. And here's a screenshot of something that you might see in your own Looker deployment. And the point I'll make here is that BI queries require a lot of complex logic. Oftentimes, you're doing full table scans, multi-table joins across columns that don't have appropriate indices, a lot of window functions, a lot of aggregates. These are the kinds of queries that your DBAs would kill you if you ran on production. But an interesting point is that these are also the kinds of queries that to build advanced capabilities would be really, really powerful. So, and I guess one way I describe it is, when you're building the application, you sort of have a happy path in mind, and you build the indices on your columns with that happy path in mind. But the more people that are joining your company and the more people that have these creative ideas about what to do with your data, those indices don't scale. So these kinds of queries become, I guess, more and more common as your application grows and as the people in your company grow. So continuing on with the data warehouse journey, we started off. Our production databases are on MySQL. We had Redshift, the data warehouse, and we had a lot of custom ETL pipelines that would move data from MySQL into Redshift. We had basically two modes. These would run nightly, and you would either append new rows from a table in MySQL into the warehouse, or you would just blow away the whole table and rebuild it. I'm sure this sounds familiar to a lot of you. So here's an example. This is a table that you might have in MySQL. You have a version of that in Redshift or Snowflake or whatever your warehouse is. And at the stroke of midnight, boom, you get all these new rows. And that's great because your data is up to date. Unfortunately, unbeknownst to you, your data model is mutable. So all of these rows have updated in the meantime. And you've really invalidated the state of your table. So and I guess one point I'll make here is this is, for business intelligence purposes, probably OK. In most cases, 1.5%, 2% changes in the data where it's not totally consistent with production, totally fine. If we have 1 million users versus 1,010,000 users is not that big of a deal. But if I'm sort of presenting a product to the user, and in one view I tell them, this month you ran 100 miles, and in another view I show them, this month you ran 70 miles, that's not going to fly. So in this old world, we had this set of nightly jobs. There's no SLAs on the data freshness. Data could be up to a day old. And there's no guarantees on, is your data going to be consistent with your production databases in the warehouse? And again, this is good enough for business intelligence, but for us to consider that data good enough for product, we would say, we put some arbitrary bounds on this, where the data needs to be at least an hour fresh, and we need to be absolutely certain that this data is consistent with production. So how do we achieve this? And I'm sure since a lot of you here are Alooma customers, you're aware that MySQL has this neat thing called the binary log. So we started exploring options of how can we exploit the binary log to build sort of a way to get data to be more consistent from MySQL into our data warehouse. Now, there's a lot of resources online about how to do this. One thing, so in Seth's talk, he talked about Facebook is sort of the brag about how great your personal life is. I think software engineering blogs are the company or the corporate version of look how great my company is. I read a lot of software engineering blogs. And this is an example of a great series. I think it's 10 parts. And it's about how Yelp built their change data capture system. It's how they built basically a system to read the binary log and replicate to their MySQL data warehouse. Really interesting to read. But what I find even more interesting is some of the metadata around this. So there's 10 blog posts here. And it's written by 8 different engineers over the course of 2 years. So the point here is that to build this product took Yelp a lot of resources and a lot of time. It's a difficult problem, but also it's an important problem because they cared so much to put this much effort into it. So and I would also say in the technology world, this is expensive. The most expensive, most scarce resource by far is engineering time. So how do we, Strava, as a data engineering team of 2, do this? And the answer is Alooma, as you may have guessed. So rather than try to build it ourselves or staff up to do it, we looked out to see who's doing interesting things in this space. There's a lot of ETL vendors out there, and a lot of them have sort of their niche that they're going for. And I think one of the things that we were really looking for was somebody that could handle our scale. And we don't have a lot of, I would say, absolute scale. Like, we're not a Google of the world. We're not a Netflix of the world. But we do have a lot of scale for the number of employees that are at Strava. So the data team at the time was 2 people. And I think at the time we were doing something in the range of like, I would say our transactional DB was going through like maybe 200 million transactions a day. So fairly high volume. Let's see. OK, so the state we're in today, Alooma is constantly streaming data into our data warehouse. We have a max 1-hour latency, and we have consistency guarantees with production. And this is going to enable a lot of those really cool use cases that I was describing earlier that were previously really difficult to build, really difficult to maintain from an operational standpoint. I'll talk about one of my personal favorite examples where we were able to use Alooma. And some of you, if you've heard of Strava, you may have heard of this thing called the global heat map. So the global heat map is a visualization of literally trillions of GPS data points. So every time a user uploads their activity, they're basically giving us a GPS track. And we just said, throw it all on the map. Like, what does it look like when you put all of those points on the map? And there's a lot of software engineering that goes into building this. And a lot of that I'll actually gloss over because the interesting thing to me, and I think I'm unique in this regard, is not how do we build this, but how do we make it such that we can actually release this to the public? Because you can imagine there's a lot of concerns around, like, is there sensitive information here that we might not want to release? So one example, let's say you have a cabin in the woods, and there's nobody else around. Let's say if I were to zoom into your area in the global heat map, it looks like this. But all of a sudden, you build like your own trail network in that cabin in the woods, and you're doing these runs and these rides on that trail network. And it's really hard to see in the chart here, but there's this tiny little orange blip there. And that indicates heat from somebody doing an activity in that region. One thing we absolutely do not want is people who don't want to be found to have their like little cabins and little hideaways found on this heat map. So one thing we enable within that application is really, really good controls around how to make your activities private, how to hide them, how to make sure they don't show up on here if you don't want them to. But it's a really, really hard problem to say, I want bulk access to every single piece of data, but also respect somebody's privacy settings. And that's where Alooma comes into play. With Alooma, we can use Snowflake to basically grab billions of privacy settings, ingest them into the process that aggregates all this GPS data, and basically all that data, like one of the themes that kept coming up in the Alooma cab this morning was that all of your data is a join away. Before we had Alooma, joins were like joining against privacy settings, massively difficult. But with Alooma, now we have it there in our data warehouse. We're confident that we can respect people's privacy settings while still creating really cool visualizations like that. So that's all I had for today. So happy to entertain any questions. Yeah, that's a really common question. So the question was, I mentioned in the beginning we were using Redshift, and later on in the talk I mentioned Snowflake. I think it sounds like a lot of people in the room today are Redshift users. Redshift, I think we had at some point, and we could have been better about keeping sort of metrics around this, but the sort of internal metric I tracked in my own head was, how often am I getting slacked? Redshift is slow. Like, why aren't my reports running? So that's something that I kept hearing consistently again and again and again. At some point, I looked up, like after getting sick of hearing this many times, I looked up like the P95 latency of a query, and it was something absurd, like 20 minutes. And if you do the math, if 5% of your queries are taking longer than 20 minutes, then you're spending at least like 40 hours of the company's time is blocked waiting on Redshift queries to complete. To me, that's unacceptable. So one of our explicit goals moving to Snowflake was to get that down to under 5 minutes. But yeah, I guess Snowflake's been really good for us. I don't really know what else to say. I'm sure a lot of people here can sort of tell a similar story where bumping up against concurrency issues, scalability issues, all that sort of stuff.